Welcome everybody. This is the second lesson of our input-output organization. This is the lecture 2, the next consecutive lecture on input-output organization. In this particular lecture, we will concentrate on different modes of data transfer. Three types of modes of data transfer are available here under synchronous or asynchronous type of data transmission. Data transfer between the central processing unit or main memory with I/O devices may be handled in a variety of modes. There are three possible ways. One is programmed I/O, another one is interrupt initiated or sometimes called interrupt driven I/O, and a popular one, a third one is DMA or direct memory access. This one is the pictorial representation of modes of data transfer. On the left hand, this is the programmed I/O. Second one is interrupted initiated or interrupted driven, whatever it is. And lastly, in our right hand side, the DMA or direct memory access. First of all, what is programmed I/O? This is the software oriented method where CPU is needed all the times during data transfer between any two devices. Programmed I/O operation are the result of I/O instruction written in the computer program. Each data item's transfer is initiated here by an instruction in the program. Generally, the transfer is to and from a CPU register and peripherals. Transferring data under program control requires constant monitoring of the peripherals by the CPU. Second one, the interrupt initiated I/O, a special one actually. In interrupt initiated I/O, the programmed I/O method we have already seen. The program constantly monitors the device status. Thus, the CPU stays in the program until the I/O device indicates that it is ready for the data transfer. This is a time-consuming method or procedure, since it keeps the CPU always busy needlessly. It may be overcome by allow the device controller to continuously monitor the device and raise and interrupt to the CPU as soon as device is ready for the data transmission. The CPU momentarily stops the task when it is processing and branched to an interrupt service routine or ISR sometimes called, or sometimes it also called IO routine or interrupt handler to process the IO transfer. Actually, IO routine, interrupt handler and interrupt service routine or ISR all are same, and then returns to the task it was originally performing. Thus, in the interrupt initiated mode, the ISR software performs data transfer but is not involved in checking whether the device is ready for data transfer or not. And in the third one, the DMA, the most popular one actually, popular mode of data transfer, to transfer large block or data at high speed, this particular method is used in modern days of computer. A special controlling unit may be provided to allow transfer a block of data directly between a high-speed external device like magnetic disk and main memory, without continuous intervention by the CPU. This method is run. DMA transfer are performed by a controller circuit that is part of the IO device interface. This circuit is called DMA controller. The DMA controller performs the functions that would normally be carried out by the CPU when accessing the main memory. During DMA transfer, the CPU remains idle or may be utilized to execute another program that are not related to the transmission, and CPU has no control of the memory buses. A DMA controller takes over the buses in place of CPU to manage the data transfer directly between the IO device and the main memory. The CPU may be placed in an idle state using two special control signals. One is called hold and another one is called HLDA. HOLD and HLDA. HLDA is hold acknowledgement actually. HLDA. A stands for acknowledgement. Let's have some brief idea on programmed I/O technique. Here, the transferring of data from I/O devices to the memory with the help of handshaking procedure is done. The device transfers bytes of data one at a time as they are available. The device places a byte of data into the bus when available in the I/O bus and enables its data valid line or DVL. The interface accepts the byte into its data register and enables its data accept line. A flag bit is then set in its status by the interface. This is the common procedure of programmed I/O. Thus, there are following four steps are performed by the CPU to transfer each byte of data in this particular technique. 1. Read the status register of the interface unit. 2. Check the flag bit of the status register. 3. Read the data register of the interface unit. And finally, send the data to the memory by executing stored instruction available in the architecture. In interrupt driven or interrupt initiated I/O, here the CPU responds to the interrupt signal by storing the return address from the program counter, sometimes called PC register, into a memory stack or into a processor register, and then control branches to an ISR program that process the required I/O transfer. The way that the CPU chooses the branch address of the ISR varies from one unit to another. In general, there are two methods are accomplishing this. One is called vectored interrupt and another one is called non-vectored interrupt process. In vectored interrupt, the source that interrupt supplies to the branch information mapped to the CPU. On the other hand, in a non-vectored interrupt, the branch address is assigned to a fixed location in the memory. These are the difference between them. We have already talked about HOLD and HLDA type of signals related to DMA. The CPU activates the HLDA or hold acknowledgement output to inform the external DMA controller that the buses are in the high impedance state. The control of the buses has been taken by the DMA controller at that moment and that generated the bus request. After transferring data, the DMA controller disables the hold line as well as the CPU then disables the HLDA line from its side. There are several advantages of DMA type of mode. First of all, it is a hardware method, whereas programmed I/O and interrupt I/O are software oriented methods of data transfer. DMA is the sole type of mode that is actually a hardware method. DMA modes have several advantages, including it actually capable to transfer high speed of data transmission between two devices. Since CPU is not involved during actual transfer, which occurs between I/O device and the main memory. Secondly, parallel processing can be achieved between CPU processing and DMA controllers I/O operation.